Ladies and gentlemen, please welcome Chief Technology Officer and Senior Vice President of R&D, VMware, Steve Herod.
Hey, everybody. Hope you're hanging in there and got the ice cream recently. Keep you going. It's a pleasure to be able to welcome our tight partner NetApp to the super session here. We're doing a lot together. We have a very common vision, as we've talked about this morning, and really focusing on a lot of the building blocks for that together around infrastructure that's efficient, automation, and management. So it's my privilege to introduce Manish up on stage, who's going to talk about how NetApp is doing these products. Manish is in charge of all of the products and the product operations across the different things we do together, but most importantly, he's in charge of the VMware integration work that's happening, and we have engineers working together on a daily basis. So please join me in welcoming Manish Goel to talk about NetApp and VMware together. Thanks.
Thank you, Steve. Good afternoon. I think there is a clicker here. So the context of the conversation today is all along been that there is a transition going on in IT architectures, and the transition is driven by delivering IT as a service. And IT as a service, both in terms of being able to deliver IT as a service and the desire to consume IT as a service. The need for this change is not new. The drivers for change have existed for a while. The drivers have been explosion that's been going on in computing capacity, the explosion that's been going on in data growth, and all of those have been going on for a while, but the current economic events, the recession in the industry, and the increasing pressures on the CIOs are just making it harder and harder to balance the budgets and focus on anything other than sustaining projects. Couple that with the fact that the existing architectures, the dedicated siloed architectures and the aging architectures are making it really hard because there's so much inefficiency built into these architectures. There's so much waste built into these architectures. They're so static and so inefficient and complex that transitioning to IT as a service future becomes that much more difficult. So that's been going on for a while. That's probably a 10-year-old story. What has changed is the fact that in the last couple of years, what's brought a different level of urgency to this conversation is that in the last couple of years, delivering IT as a service externally by service providers has become a reality. Whether it is software as a service and applications as a service like Salesforce.com, whether it is IT as a service from people like T-Systems or Terramark, whether it is processes as a service like backup by Iron Mountain and SunGuard, that has become a reality in the last couple of years, and that has now established a competitive benchmark that the decision makers, specifically the CIOs, have to respond to. In the past, even though the drivers existed, the reason why the CIOs did not have to respond to that is because there was no other alternative, which was a better alternative than doing things just the way they were. But now there is. Because now there is an alternative, the decision makers, the CIOs, only have one of two choices. They can either deploy these services and go to external service providers, or they can re-engineer their architectures and make their internal architectures be ready to deliver IT as a service internally. This is the whole debate about internal clouds and external clouds, public clouds and private clouds. But at the core of that discussion is the fact that now that change has to be made. Whether the CIO delivers a private cloud by internally re-architecting or begins to look at their entire service catalog and say, which of these services I want to be in the business of delivering and which services I'm just going to buy on a per-use basis, that's a decision they cannot escape anymore. As they are making that decision, in either of those two cases, a shared infrastructure, both at the server level and at the storage level, becomes a requirement. So as we go through that, in the journey that they have to make internally, there are 4 steps that have to happen for the CIO or the IT architect to deliver a shared infrastructure. It starts with standardizing your architectures. Without standardization, there is no sharing, and so the architectures have to be standardized. All the various applications, all the various compute architectures, the networks, they all have to be standardized. So that's the first step. The second step has to be centralized. Again, if it's distributed across 180 different data closets or data centers, it's very hard to deliver shared infrastructure and deliver IT as a service. So that becomes the next step, that there has to be a centralization. Now, clearly, centralization versus decentralized IT is a debate and the pendulum that keeps swinging back and forth. The current drivers to deliver IT as a service are definitely making that pendulum swing back towards centralization and standardization. The third step then becomes, how do we virtualize everything? Clearly, server virtualization has been a critical driver of this movement, but now the discussion has moved to, as we think about server virtualization, which, by the way, ends up becoming a critical aspect of creating the initial standardization that I talked about, because what server virtualization is beginning to do, as Steve and Paul talked about earlier this morning, is homogenizing everything which is below the compute layer. Because it homogenizes to anything below the compute layer, there is a level of standardization that's beginning to take place from an architecture level. So then the next step becomes, how do we virtualize everything, the servers, the networks, the storage? And then the final step becomes, even if you virtualize everything, there's an enormous number of things that you can do to optimize for flexibility, optimize for efficiency, and really looking at the technology choices which are very, very highly optimized for virtualization. And I'll talk about that a little bit more. This is what Steve talked about. The context in which these discussions are taking place is there is an infrastructure layer that needs to be virtualized and shared. There is an application development layer and an application deployment layer that needs to be, again, standardized and shared. And then there is an end-user computing layer, which again needs to be virtualized because the end-user computing devices are beginning to get very, very diverse, but the service delivery on those end-user computing devices remains the same. So that's the context that Steve painted this morning. So if we talk about the infrastructure, what's going on in the infrastructure because of server virtualization is the fact that server virtualization, as I said, is bringing a level of homogenization. And so underneath that, the first step that took place as server virtualization began to get adopted is the fact that the zones of virtualization began to happen. A whole bunch of different applications, which in the past had existed as disparate applications, began to come under the layer of virtualization, and to the rest of the infrastructure, that looked like a common architecture. Now the discussion is beginning to move to internal clouds and external clouds, and today Paul was talking about hybrid clouds, and the discussion is now beginning to take the next step, which is once we have the internal clouds and the external clouds, how do we provide a level of standardization so that there can actually be application transfer and context transfer between the internal clouds and the external clouds. Now, my view is that mobility between the internal and the external cloud, the context switching between the internal and the external cloud, is not something that's going to be dynamic and happen willy-nilly all the time. Now, clearly from a compute capacity where there's a need for some sort of a buffer compute capacity, there's an application that just needs a few more CPUs, that's a very specific use case. But in general, the movement between internal cloud and external cloud is going to be driven by some sort of a conscious decision of how an end-user organization is attempting to deliver that service. At some point, the decision makers are going to say, this is a service we do not need to be in the business of owning the delivery for, and therefore, what we are going to do essentially is we are going to move this service outside, right? So there is a nuance that gets lost in terms of the movement between internal and external clouds, as in this is going to be something that is going to be automagic and it's going to happen very, very frequently. Our view is that it's a static event, right? So the capabilities have to enable that. And to make the second aspect of this, again, the nuance of movement between internal and external cloud is the fact that data is very, very hard to move. We are storage specialists. We think about storage. Data doesn't change context that easily. So as we're thinking about internal and external cloud, again, from a business application standpoint, what it means to us is how do we make sure that if the compute context moved, that they still have access to data at the storage layer, and how does the storage layer enable that? And then, if there is a business decision made to move a certain service or an application, how does the data context move with that? So that's the context, that's the implication at the infrastructure layer. But as we are going on this journey, and people are deploying that and more in a larger and larger scale, server virtualization ends up creating economic challenges and other challenges at the storage layer that the storage equipment providers have to address for this promise to come true. And the kind of challenges, just to go into a little bit more detail, on the journey to server virtualization, and as a result, on the journey to a shared infrastructure, there is a series of new challenges that got created at the storage layer. And the new challenges are, the first one is economic challenge. You have now taken a set of applications that were running in a direct attach environment, which was using direct attach storage is cheaper than network attached storage. So essentially, it was taking cheaper storage, and now we have moved it to more expensive network storage. And that creates an economic disincentive. So how do we make sure that that's not an economic disincentive and there are other capabilities that overcome the economic disincentive at a raw dollar per gigabyte that got created? The second challenge that ends up getting created is, in a non-virtualized environment, largely speaking, the server real estate was very, very cheap. A typical server was utilized only to 5 or 10 or 15%, which is the reason why server virtualization became so popular. And when the server resources were only used for 5, 10, or 15%, there was a whole bunch of other background processes that could run on server resources like backup agents. But suddenly, with server virtualization adoption, server real estate became really expensive. Suddenly, what was New Jersey real estate suddenly became Manhattan real estate. Now, when you have a choice of saying, I can put another virtual machine on that server, versus I can use the server resources to run some background agents, what choice would you make? So then, this is where it goes to the point that Steve was making earlier this morning, which is, how do we make sure that there were capabilities that were running at the compute layer earlier that we can now offload onto other pieces where it more naturally belongs? So server offload of things like backup and disaster recovery now becomes a requirement that the storage layer has to address. The third challenge that server virtualization ends up placing on the storage layer is response time expectations have changed completely. In a physical environment, a person's expectation of what it takes for a physical server to get implemented was 8 weeks, 10 weeks, 12 weeks. Once I want a server and an application, if I, given my notice, IT will deliver me a physical server in 8 to 12 weeks. Now, everybody wants it at the click of a button. I want a new virtual machine, I want this application, I want it now, right? So the response time expectations have changed completely, and the storage layer has to have techniques and capabilities that help you deliver that kind of a response time. And finally, as I said, data mobility is becoming a requirement because now the application is not tied to a physical instance of a server. The application can now move instead of failing over. So as you begin to reduce the tie between the application and the physical server, data has to start becoming much more mobile. The data has to follow the compute and the application. So these are the 4 new requirements that get placed on the storage infrastructure on the journey towards the shared infrastructure. Without addressing these, none of the promise of shared infrastructure comes to bear because you get the benefits on the server side. You just end up paying for it in terms of far more complexity on the storage side, and the benefits don't realize. NetApp, because of its virtualized operating system and the fact that we have, right from the beginning, architected our storage layer to have a logical layer which separates the physical units like disks or systems or even vendors and locations, ends up becoming the perfect complement to what is happening with VMware and server adoption. It starts there. The second area of focus from a technology standpoint that NetApp brings to the table is the fact that we have an enormous focus on storage efficiency techniques. How do we make sure that we can reduce the amount of data so that what is logically being seen by the users and the applications is much, much bigger than what is physically actually being stored in terms of blocks on the disks? And there are a variety of different techniques to that, whether it is data reduction techniques like deduplication, or there are cloning and virtual copy image creation techniques like cloning. There's a variety of different techniques which help reduce the amount of actual storage and drive an efficiency that goes to the initial point I was making, that there is an economic disincentive in server virtualization that is inherent in that move. The third aspect of it then becomes, how do we make sure that now we begin to create a management and an automation framework? Because now there is a necessary requirement to say, how do we get a automation all the way from, this is the virtual machine, this is the network, this is the storage, and we can get a vertical view, because the vertical view is now no longer being afforded to us through a physical infrastructural view. Now the vertical view has to be created logically on the fly. So that requires a whole bunch of different techniques and tools to create automation and management. And all of that has to be integrated very deeply into VMware, all the various VMware control planes, so that it can provide a single view. In fact, just give you a little bit of a story. Steve talked earlier this morning about vStorage APIs and the fact that vStorage APIs are able to offload a whole bunch of different capabilities that can now be done at the storage layer. The reason why they can offload, in fact, when we started having these conversations with VMware right in the beginning, the initial view inside VMware was we need to provide APIs which are standard across every single storage layer. And as those discussions progressed, it became pretty obvious to both sides that there's a whole bunch of things that the storage layer, an intelligent storage layer, can actually offload. And that's really what led to a thought process that Steve articulated this morning of saying, hey, what we want to do is to be the control plane, and we are going to call on all the various elements of the physical infrastructure, whether it's the network or the storage, and we're really looking for intelligent infrastructure partners which can offload as much of those capabilities because they much more naturally belong over there. So that's the vStorage API integration. So coming back to it, just taking a look at what are the specific technologies that are now necessary to address the four challenges I talked about: the economic challenge, the server offload challenge, the data mobility challenge, and the provisioning time challenge. So storage efficiency, deduplication, compression, cloning, all of those are going at the heart of the economic challenge. Then you take a look at the server offload, the fact that disaster recovery and backup can be done at the storage layer, not necessarily requiring agents to sit at the server layer, becomes necessary to implement that. Then you get to response times, and again, techniques like cloning, which essentially can create logical copies of the same data over and over again, whether it's boot images in server environments, whether it is boot images in VDI environments, which I'll talk about in a minute, end up becoming critical requirements to reduce the response times, not just the storage, but the response time. And finally, very tight integration of mirroring techniques which are storage array-based, integrating into tool sets like SRM from VMware, provide a mobility context where now the data can follow the application. So these are the kind of things that we are thinking through together with VMware, where we're saying, hey, to get to shared infrastructure, server virtualization is what enables that. It ends up creating a whole set of challenges on the storage layer that now need to be addressed. When you talk about the storage layer, there is a set of challenges that need to be addressed and specific technologies that need to go after that. Net of it is that the requirement of the storage layer of the future, which builds this shared infrastructure, which helps the customers deliver IT as a service, is very different than in the past. The architectures of the past were very static architectures. They assumed a very low ratio between the compute devices connected to the storage devices, and their focus was on performance and resiliency, not on intelligence. The architectures of the future have to have 7 fundamental requirements that will help create IT as a service. It has to start with unified architecture. The discussion has changed. The discussion has to be about unified architecture because, frankly, if you don't have unified architecture, you can't build a shared infrastructure. And unified architecture is much bigger than multi-protocol. Multi-protocol is simply one aspect. What unified architecture really is an ability to run any kind of a workload at any point in time on the most cost-effective way on the same architecture. So the discussion starts with unified architecture. It has to scale to tens of petabytes, thousands of users, thousands of VMs, and it has to scale beyond physical limits of storage boxes. It has to be able to span multiple storage boxes, multiple locations, multiple vendors. It has to get to integrated data protection where backup and disaster recovery capabilities are integrated at the storage layer, not relying on external tool sets which are outside of the storage layer. The operation has to be completely nonstop. Every single customer I talk to, when I say, what's your requirement of your IT storage infrastructure, they say, it has to be non-disruptive. I've heard that for the last 10 years. I think that conversation just turned from nice to have to must have. Because here's what ended up happening. In the past, when it was a dedicated environment, every CIO that I talk to, they all take downtimes, right? I mean, every weekend you take a downtime in your operations. When you're taking a downtime, you only had to go inform a couple of different users to say, we're taking a downtime, your service is going to be down, so, suck it up. That was a conversation that people didn't like, but they could live with. Now, as we are going to a shared infrastructure, you don't know how many users get impacted. Because you don't know how many users get impacted, now what's happening is every weekend that we're taking a downtime, you're informing every single user to say that my infrastructure is going down. And in the words of one CIO, she said to me, I am doing exactly what I was doing 2 years ago. 2 years ago, it was okay. Now my end users think that my environment has become completely unstable and they want to fire me. That is the unintended consequence of shared infrastructure. So every element of that infrastructure, including storage, has to make sure that we're delivering a nonstop architecture. And other requirements like multi-tenancy. Paul talked about how we're beginning to now create logical entities, logical virtual machines, logical tenants like either applications or business units, logical data centers even. And as we are beginning to move to these logical entities, these are tenants that are sitting on the same shared infrastructure. Probably the best analogy of that is people move from single-family homes to apartment buildings. When you live in an apartment building, you're sharing common space, but at the same time, you want your own kitchen, you want your own bedroom, and you want to make sure that your neighbor doesn't have access to your bedroom and your kitchen. You want a front door, and you say, the key to that front door in my apartment, which is a part of the common space, is only mine. And I can decide whether I want a one-bedroom apartment or a two-bedroom apartment or a three-bedroom apartment. That's a choice I can make. But once I decide that this is my apartment, I don't want my neighbors coming in there. That's multi-tenancy. That's secure multi-tenancy, where the security in a multi-tenant environment now needs to be logical. And because physical limits are no longer there to help create isolation, new techniques have to be developed because now the isolation has to be done at a logical level. And the isolation has to be done integrated all the way from the application to VM to the network to the storage. And then storage efficiency and service automation and the other things I talked about. So there is a new set of requirements in the storage infrastructure. As the IT architects are thinking about what to build, they have to go and build a different architecture. Some of the things that change as we're thinking about this shared infrastructure, the key performance indicators change. How many terabytes can a single operator manage? Typical numbers range anywhere from 40 terabytes, 50 terabytes, 60 terabytes. In a shared infrastructure, the requirement is going to be multi-petabytes. We have customers who are managing 2 petabytes per single storage administrator. That's a requirement of a shared infrastructure. All of the service level and response times need to change to a matter of minutes and seconds, not a matter of days, weeks, and months. How much time it takes to provision, how much time it takes to restore, how much time it takes to deploy. All of those service level conversation is changing to a matter of minutes, and it can be done. The total cost of ownership, the conversations as we go to a shared infrastructure, that gets reduced by 20, 30, 50, in some cases 70 and 80%. So the key performance indicators change. And if these sound like bold claims, we have guarantees where we can walk into every single customer and basically say, whatever your current architecture is, we guarantee that we'll reduce your storage cost by 50%. This guarantee has been in place for more than a year. enormously successful because that helps the customers understand what is possible. It's no longer just a marketing claim. This is reality. It hits the checkbooks, and this is possible. It's here today. So now let's go to what the title of this workshop was, and let's talk about virtual desktop infrastructure. Paul and Steve again talked this morning about saying there are three levels. There's the infrastructure, there's the applications, there's the endpoint devices. And, I got to admit, I started this whole VDI conversation about 18 to 24 months ago being an enormous skeptic. And my teams internally got really frustrated with me because they would say, hey, they obviously could see better into the future than I could, but they were enormously frustrated because they would say VDI is a huge opportunity. And my mental model was still formed by the fact that VDI has been in existence for a while, and VDI has been a very niche application. VDI is not a new concept. It's existed for a while, and it's been a niche application. But as I've started talking to customers, and in the last 18 months, as these conversations have progressed, a few things are becoming more clear to us. The conversation started with the typical, I just want to be able to reduce my cost and complexity. The whole desktop IT cost is very high. The management complexity is very high. I have thousands of end users. Why am I in the business of giving them PCs every 18 months? I had a customer who basically said, look, what if I just give every new employee a $1,500 allowance when they walked in, and after that they could just buy any PC they wanted? I do not ever want to buy another PC. I never want to have another standard for a PC in my environment. That's where the conversation started. In the last 6 to 9 months, the nature of the conversation is taking another turn with the advent of things like iPads. And I have never seen a new technology just invade into the boardrooms and into the corporates like iPads have, right? Steve was absolutely right. Every single meeting I go to, half the people have iPads. Because why would you carry a laptop when most of what you carried a laptop for was checking email, and you can check it as effectively on an iPad, right? So the nature of endpoint devices is changing, and endpoint devices are becoming very heterogeneous, but the service that they're being used to consume remains exactly the same. And that's a conversation that's beginning to take place in the last 6 months, and that's putting an enormous amount of pressure on VDI. There's a couple of other interesting drivers for VDI as well, which weren't obvious to us right in the beginning. I was talking to a customer a couple of months ago, and the reason why they want to go to VDI is not because they want to reduce their cost. It's not because they want to support iPads, but they're in a transaction business and they want disaster recovery. What they're worried about is that they have 50 traders, which all sit in a single office, and if for any reason that office went down, they don't want to lose their traders' ability to work, and they want to move the traders to another virtual office using VDI and get them up and running, because the loss of productivity from these traders is going to run into millions of dollars for them. They just can't afford that. So there is a disaster recovery aspect to keeping your workers productive, especially in transaction environments, that is also beginning to drive VDI. Another conversation, very interesting, is the US Patent Trade Office. They realized that they were so far behind in their ability to actually process all the patent applications they were getting that they needed to add 3,000 new patent assessors. But the only way they could get 3,000 new patent assessors was they could not move 3,000 qualified people into Washington, D.C. They had to hire these people all over the place. So as they were hiring all of these patent assessors all over the country, they needed to move to a VDI infrastructure to enable all of these patent assessors to access the services, but at the same time meet compliance requirements. So now, as the customers are thinking about VDI, there are other drivers, secondary drivers, which are beginning to emerge, which makes for a compelling case for VDI. So this is almost one of those things where there's a turning point, and what started out as I just want to reduce my cost and complexity is now turning into more of a business enablement conversation. And as that conversation gets into a business enablement conversation, as I said, we originally started thinking about VDI in terms of saying it's a niche use case and it's a niche application. What this chart really shows is there are two dimensions to the VDI conversation. There is the user mobile or non-mobile? Then there is the second dimension, which is the user a transactional user? Is the user a content creator? Or is the user a content consumer? And typically in the past, the VDI conversation has stayed limited to transactional non-mobile users. The conversation started from the bottom left. Increasingly, over the last couple of years, the conversation's expanding to cover all the other various use cases. In fact, the announcement today by VMware of VMview 4.5 is targeted at the top right corner, which is a content creator mobile user. Now, I am a content consumer. So an iPad is a perfect device for me because all I do is consume content. I don't create my PowerPoints. I think the only thing I create is emails. And iPad's a perfect device for me, so I'm a perfect candidate for VDI. If our IT group could basically say, that Project Horizon thing, by the way, I just loved it. I want it. I want it today, right? Because if I could get it today, that's perfect for me as a consumer. So, but now the technology is beginning to now basically say, for this technology to become real, and for this to become a big decision as opposed to a tactical decision that the IT organizations are making, it has to be pervasive. It has to cover all the various use cases that we have. It has to cover the mobile and non-mobile. It has to cover the transactional, the content consumer, and the content creator. And as you heard from the announcements, is beginning to cover all the various use cases. So one of the things that VDI does is it sets a set of challenges that are very unique to the VDI use case that have gotten in the way of VDI becoming a reality in the past. And here's the nature of the challenge. VDI has changed the conversation from tens of servers attached to storage to thousands and thousands of users attached to shared storage. And the question and the conundrum that it creates for the IT architects is, how do we deliver VDI in a way that we can meet the performance requirements of VDI and at the same time do it at an economics that make the business case be justified, that creates an ROI. And the reason why that problem is specific to VDI and the problem gets created is, as in any architecture, as people are thinking about sizing that architecture, you're always thinking about what's my average load and what's my peak load. And you have to size the architecture to peak loads. In VDI, the peak loads are driven by boot storms. Because the characteristic of a VDI is there's a whole bunch of end users who all show up typically at around the same time, between 8 and 9 a.m. in the morning. They all log on to their laptops or their endpoint devices, and that ends up creating an enormous boot storm. In the past, when these were endpoint devices, you had local hard drives. So you had thousands and thousands of local hard drives, so boot storms weren't there as a phenomena. But the moment you go to VDI and you create a shared infrastructure, now you have boot storms. So the infrastructure has to be architected for the peak load, which in this case is boot storms. But the moment you architect it for boot storms, the only way you can do that is by so thinly striping it, because the unit of performance ultimately is the spindle. And so now you need so many spindles to be able to make sure that there's no boot storms, that the business case gets blown out of the water. Because now, if you're going to take hundreds and hundreds of very expensive network storage and replace hundreds and hundreds of very cheap laptop storage or desktop storage with it, and then you now need a lot of that because that's the only way you can address boot storms, which have now accentuated the problem, the business case isn't there. So that's been the challenge. How do we address the fact that there is a performance requirement which is unique to VDI and an economic pressure, because the whole point of doing this is to spend less, not more, and how to do it all together? So I'll place a bold claim out there that nobody in the industry can make VDI at scale a reality like NetApp can, because of a set of technologies that are necessary to address that issue of performance and economics. Let's take a look at what happens in this particular use case. What is the boot storm problem? The boot storm problem is hundreds of end users showed up between the hours of 8 and 9. They all logged onto their computers. And when they logged onto their computers, at the same time, there was an enormous amount of read I/O that got created. And all of that came down to the shared infrastructure, the shared storage, and now there's a bottleneck. That's the bootstorm problem. Now, there is a solution which is, let me just provision a lot of spindles underneath that so that I can address that, but that blows the economics, as I said. What we are able to do is take flash storage and the capabilities of flash, integrate that into our operating system as a memory cache, and offload all of the read I/O load that comes because of the bootstorms, and U-turn that at the flash cache layer so that it never needs to go to the spindle. And by doing that, we can now deliver a storage system that can be sized to its capacity, not to the peak capacity because of bootstorms. And because the entire read I/O load, which is very specific to a period of time, which is the login and the booting, is offloaded in a very cheap fashion using flash caches, now you can address both of the issues at the same time. Now, there is a lot of conversation in the industry in the past about saying, let's use SSDs. But that doesn't address the problem either, because you have to address performance and capacity both at the same time. The challenge with SSDs is the fact that while SSDs can deliver the same performance characteristic, what it doesn't help is addressing the capacity requirements. And on a dollar per IOP basis, SSDs are really good. But on a dollar per gigabyte basis, the profile of SSDs isn't there yet. There is still a 10x economic disadvantage on a dollar per gigabyte basis. So SSDs take us back into the same conundrum, which is I can either address performance or economics, not both. But this approach, by using dense SATA drives, which are very cheap economically, and offloading all the read I/O, which is very specific to bootstorms, using flash cache, enables both performance and economics. So going back to the picture that I was talking about, what happens? You size an architecture for capacity. Then you can do one more optimization on that architecture. The optimization we can do is, because these are all thousands and thousands of VDI devices which are all look and feel exactly the same, there's an enormous amount of data duplication that exists. So now we can apply storage optimization techniques like data deduplication to reduce the capacity requirements even further. So that makes the curve look a little bit like this. This is a pictorial representation, but essentially what it's trying to say is you actually need even less capacity. But because you now apply deduplication to address the economics and now you need less capacity, the net result is now we made the performance problem even worse. So that's where flash cache comes in, and you apply flash cache, and you U-turn all of those read I/O, and that helps you solve that issue. And the final piece of that technical story or the technical puzzle ends up being our operating system is so write I/O optimized that we address not just the read I/O, but on a regular runtime basis, the operating system is write I/O optimized, so that reduces the performance requirements of the architecture even more. So the net result of that is where you needed, let's say, X amount of storage to meet both the performance requirements of this deployment, now you need a fraction of that X amount of storage to deliver the same performance requirements, and that makes the business case hang together. That makes the ROI of VDI real, and that's really what's happened in the last 8 to 12 months. As IT architects have begun to think about this, they're beginning to find that by applying these techniques and these capabilities, this is a business case that actually hangs together. They can take it to their CFO, they can make it work, they save money, and they meet all the needs of the business, whether it is that I, as an executive, want my iPad to work, or it is that I have compliance requirements, I have cost requirements, etc. So that's the cost side of it. Going back to the next aspect of VDI is the service level. As I said, the service level expectations have been reset permanently. Service level expectations have got from, hey, it's okay to wait days and weeks and months, is become a matter of I only have minutes or I want it now. We're definitely in the I want it now environment. And I should be able to get it now. Why is it that I can go to Amazon and with the click of a button, I can get that capability, and why can't my IT environment, my IT group, deliver me that capability with the click of a button? So provisioning of VDI environments makes that problem even harder, because now we're not talking about provisioning 10 servers or 50 servers. We're talking about provisioning thousands and thousands of end users. In fact, a conversation we were having with a customer who was using their traditional existing storage infrastructure to do a proof of concept for VDI. And as the story unfolded, we were just talking to them, and he said, I did a 1,000-person VDI POC, and it took me 30 days to provision all the 1,000 users. So as I'm now thinking of doing the next stage of the POC for the next 1,000 users, how many days do you think your technology will take? And we thought about it for a little bit, and then we said, would an hour do? And we didn't want to say minutes because we thought we'd lose complete credibility if we said minutes. But the fact is it takes minutes, but we figured that if the person's benchmark was 30 days, if we said an hour, at least it doesn't sound so ridiculous that the person completely dismisses us out of hand. Right? But that's the kind of service level change that we can bring to bear, because we can now provision by just creating logical copies, which are logical representations of all the boot images and the virtual desktop images, and that can be done instantaneously, and it doesn't require any more storage or any more space. To Steve's point about it's not just about the infrastructure, it's also about automation. We've now automated that whole process by saying there's a rapid cloning utility which can create as many copies that you want, as many virtual desktop images as you want, in a matter of seconds. So the rapid cloning utility is an example of the kind of automation that we're bringing to the process as well, which is very unique to VDI. And then finally, to Steve's point about management integration, this all has to integrate all the way from vCenter, vSphere, and VMview. So a lot of what our engineering teams are spending time on together, along with VMware, is where are all of those integration points, where are all the integration hooks, so that from view, you can get an end-to-end view of your entire, that wasn't a pun, you can get an entire desktop view without having to go separately to each layer in the infrastructure, without having to go to the server view and to the storage view separately. So that integration then becomes a part of the joint service offering that we offer with VMware and VDI environments. Just bringing it all together into a real example, a very large regional bank, they started doing 1,000-plus view desktop implementation. They started with their existing storage. And in this specific example, it was 1,000-plus virtual desktops. They needed 300 disks to implement that. And not only did they need 300 disks, they still had all the boot storm and login storm problems that I talked about. If they had to reboot, that was a multi-hour outage. And when you have a multi-hour outage which impacts every single end user, end users get really unhappy. When they moved to the NetApp storage, they were able to achieve the same thing going from 300 disks to 56 disks because of the performance lift or the performance acceleration they got from flash cache. That made the business case hang together, and all of their boot and storms, et cetera, just all disappeared. That's what makes VDI a reality. So what's going on, as Paul said, there is a new stack that's emerging for virtualization. And the new stack for virtualization, whether it's at the network with Cisco, whether it's at the compute layer with VMware, with NetApp at the storage layer, is what's enabling a end-to-end, unified, fully integrated, fully logical, fully multi-tenant architecture that becomes the basis of the new shared architecture. If you take a look at the next generation of the data center, It's one computing platform. It's one application platform. It's a converged network. It's not separate networks like IP networks and fiber channel networks, etc. It's a converged network, and it's a unified storage layer. VMware clearly provides that level of consolidation, and that begins to bring a level of homogeneity to the applications. And the net result from a customer standpoint ends up being your data center CapEx, your data center OpEx. Here it says it gets cut in half. Our analysis and our view is there is 10 times the waste that exists in current architectures. And this transformation that's taking place at the IT layer has an opportunity to address the requirements increase of up to 10x before we will need to start thinking about the next paradigm that will then help us scale beyond that. That's the level of waste, inefficiency, and complexity that exists, and moving to the shared infrastructure goes after that. That's the prize. Security becomes critical in this. You heard it this morning. And the view of security really is, how do you create a logically secure view, which is a vertical security and a tenancy view, in an environment which is horizontal and it's fully shared. So that requires a lot of ecosystem integration, a lot of ecosystem sharing that VMware, Cisco, and NetApp are all working on. So let me bring this to a close by saying, look, here's our view of what's going on in the IT architectures. Shared infrastructure is a reality. That's the future. That's where everything is headed. To get to shared infrastructure, you need intelligent, virtualized storage. We do that. The killer application that is right now on top of everybody's mind is VDI. The conversation is becoming much broader than the niche conversation that used to take place 6, 12, 18, 24 months before. And in VDI, our belief is there is no other vendor that can implement VDI at scale like we can. And as Paul said, there is a new stack emerging, the new stack for shared infrastructure. The people who belong to that new stack are Cisco, NetApp, VMware. There's a lot of people, there's a lot of experts from NetApp here, and from Cisco and VMware as well. We have a booth. We have a lot of people who would be willing to answer any questions that you have. If you want to see demos of any of the technologies that I talked about, whether it's RCU, whether it's flash cache, boot storms, we have demos of all of these technologies. So my request to anybody who wants to learn more is, go to our booth. Go find all the guys who are wearing these blue hats. By the way, thank you very much. You guys have obviously already visited our booths. All the good-looking people who are wearing blue hats over here. Thank you. And we'd love to see more of you in the blue hats. Go check out our booth. And with that, if there's any questions I can address, I'm happy to take those. I'll do my best to talk about anything I see in the industry, my customer conversations. If it gets too technically deep, there probably are smarter people than I who I'll be able to point to. Thank you.